Chapter 4 takes a look at the type of chemical reactions we're going to be dealing with. Most of our chemical reactions are going to take place in water, so it would be helpful to know a little bit about water's properties while we are dealing with solutions and reactions in solutions. Water is a polar molecule, which means that it has a slightly positive end and a slightly negative end. The hydrogen end is slightly positive, the oxygen end is slightly negative. Because these charges are unbalanced, it gives us a polar molecule. When we're looking at making things dissolve, the statement usually is like dissolves like. So we have polar molecules dissolving other polar molecules. We can also have polar molecules dissolve ionic compounds because water's charged ends will attract the ions. If we take a look at a crystalline sodium chloride compound, where the sodium ions are the small gray ions, the chloride ions are the larger green ions, the positive sodium ions are attracted to the negative end of water, the oxygen end of the water. The negative chloride ions are attracted to the positive end of the hydrogen ions. So what we have circled is sodium ions surrounded by the oxygen end of the water. What we have circled here is the chloride ions being surrounded by the hydrogen ends of the water. This pulls them out of the crystal and into solution. Other polar compounds will dissolve in water, such as alcohols and sugars, because they have polar ends. The polar end of one molecule is going to attract the polar ends of other molecules. Things that are not polar, things that are not ionic, will not dissolve in water. Things like oil, kerosene. So here is ethanol, and this is the polar end of the ethanol molecule. It is attracted to the polar water molecule, and the hydrogen end on the ethanol is attracted to the oxygen on the water molecule. What we're looking at here is a demonstration of electrolytes. Electrolytes are solutions of ions, and the strength of the electrolyte, as it says, is determined by the quantity. How many ions are present in the solution, not necessarily what kind of ions are present in the solution. We start on the right, we have pure water. Pure water is all molecules, they're polar molecules. No ions are present. Because no ions are present, no electricity can be conducted through the solution. An electrolyte means a solution that will conduct an electric current. The middle diagram is a solution where we have a few ions present, something that can ionize but only a little bit. So this forms a weak electrolyte solution. On the far left we have something where the compound has dissolved and forms 100% of its ions present in solution. It's ionized 100% is how we describe it. This would be a strong electrolyte solution. It will conduct electricity very well. So the definition of a strong electrolyte is a compound that will ionize 100% in water. A weak electrolyte solution is something that will ionize or break into ions less than 100% in a solution. So when we're talking about how much is present of substances in a solution, one way we can talk about it is the molarity. Molarity is the measure of the number of moles of a solute divided by the volume in liters of the solution. So it's moles of solute over liters of solution. Molarity is a measure of concentration, or how many particles of solute are present in the solution. Electrolyte strength, we're not looking at how much of a solute is present. We're more interested in how well that solute will ionize in the solution. So it's more of a measure of the percentage of ions from the solution that are present. One type of ionic or electrolytic solution, or two types actually, are acids and bases. There are 6 strong acids. You need to know them, so memorize them. They are the 3 binary halogen acids, HCl, HBr, HI, and then 3 oxyacids, nitric acid, sulfuric acid, and perchloric acid. There are only 6, you need to know them. Strong bases, you don't have specific bases so much to memorize as knowing the pattern that generates strong bases. Strong bases are created by all group 1 metals combined with hydroxide ions. So group 1 metal hydroxides are all soluble, are all strong bases. The other strong bases are group 2 metals, forming hydroxide compounds, but this time not all of the group 2 metals. We start with barium and include it, and the metals below it in the periodic table are also strong bases. Calcium sometimes is considered a strong base, but its problem is it's not very soluble. So when it does dissolve, it ionizes 100%, but it doesn't dissolve very well in water. So it's not usually considered. Types of reactions, we're going to look at several different types of reactions, and you should be able to, from looking at reactants, identify the type of reaction and be able to predict the products if you know the type of reaction. Start with synthesis. Synthesis, we're putting things together, synthesizing. We start with simple reactants, either elements or very simple compounds. We combine them and we get a more complex, usually only single product. Decomposition reactions go the other direction. We start with a single, fairly complex compound and we break it apart. Usually this involves heat. Our products this time are simpler compounds or elements, and we have at least 2 products. Neutralization is the next type of reaction. It's a fairly narrow range of reactions because they involve acids and bases. One acid plus one base combined in a neutralization reaction. Your products are always going to be water and a salt. A salt is a category of compounds. It just doesn't mean sodium chloride. It's a whole collection of compounds formed from a neutralization reaction. The next group of reactions are combustion reactions. Combustion means you're burning something. All combustion reactions require oxygen. Usually when we deal with combustion reactions, we're looking at organic compounds that are burning. And if we look at organic compounds in combustion, we're always going to produce carbon dioxide and water. The next type of reactions are the single displacement, sometimes called single replacement reactions, where we have an element combining with a compound. What we produce is a new element and a new compound. The element that starts out as a reactant ionizes, either positive or negative, and will replace the same sign ion in the compound. So for example, sodium would replace calcium in a compound. Chlorine would replace oxygen in a compound. Positive replaces positive, negative replaces negative. Double displacement reactions, we're starting with 2 compounds. They react and we form 2 new compounds. So the positive ion from the first compound switches places simply with the positive ion in the second compound. Sometimes we can see the results of this reaction because we get a gas or a precipitate. Sometimes it looks like absolutely nothing has happened. So a couple of definitions here. A precipitate is a product, and it's a product of a chemical reaction. How do I know I have a precipitate? My reaction container becomes cloudy, indicating that there are very tiny solid particles present, or I see solid on the bottom. So the precipitate is the solid product formed. Obvious because the reaction container now is no longer transparent, but it's cloudy, opaque, or has solid on the bottom. When something is soluble, it means it will dissolve in water. There's a cutoff definition for solubility, and that is when substances will dissolve to create a solution that is at least 0.1 molar concentration or larger. So if I can make a 0.1 or a 0.15 molar solution of something, it's defined as being soluble. If the most concentrated I can make something is 0.08 molar, it's defined as being insoluble. Okay, how come precipitates form sometimes? It has to do with attractions between ions and attractions between ions and water molecules. So on the left I have a clear colorless solution. The next one is a clear colorless solution. One is potassium chloride, the other one is silver nitrate. I combine them and I end up with a cloudy precipitate on the bottom. That's silver chloride. I have nitrate ions floating around in solution. I have potassium ions floating around in solution, and I have the silver chloride as a precipitate. Why does this happen? Again, it has to do with attraction. In this case, the attraction between the silver ion and the chloride ion is much greater. So those two ions will combine and attach to each other. Then the attraction between the silver ion and the water molecule and between the chloride ion and the water molecule. Because the silver ion chloride ion attraction is so strong, we get a precipitate forming. So now we've had a chance to go through types of reactions and look at a few definitions. We'll follow up with redox reactions in the next clip.